Hey everybody, welcome back to ModyMate's step-by-step tutorial guide. We are taking you from the beginning strokes of a model through to the finished outcome of getting instant DWGs, renderings, and quantity estimates. In our last video, we covered the process of making ceilings. Now we're going to talk about stairs. Stairs can be modeled in ModyMate two different ways. The first is abstractly via a sloped plane. The second is discretely by modeling every tread and riser. There are two different advantages to these two types of modeling. Modeling a sloped plane lets you use our schematic stair tool to place treads and risers on a sloped plane. When you click on the sloped plane, it installs procedural treads and risers that can adjust very flexibly with your model. If you were to raise or lower the top of the stair, for example, you can see that the riser heights are changing with my model. Unfortunately, there are limits to the stair tool's intelligence. So when it comes time to, for example, place a wall underneath this stair to support it, the top of the wall does not serrate to engage with the treads and risers. So there's a discrepancy in the model that may not matter early on, and in that way, there are advantages to using an abstract version of stairs in your early design process. But once you are ready to design the details of your stair, for example, the relationship between treads and risers in terms of nosings, overhangs, serrated supports within your wall, any kind of an exposed sawtooth stringer or other type of stringer, any kind of unique treads that may widen or splay out at the bottoms of stairs, winder stairs, etc., and irregular landings in the middle of stair runs, etc., it's best to model the stair plane by plane. Then you would use an assembly such as a wall or a floor for treads and risers. In this case, we have an assembly here that's a very thin piece of wood, and we've applied it to each of the planes here. We'll talk about the crafting of assemblies in a future video. This video's purpose is to talk about what type of massing graph you should be modeling at different stages of your project. But the outcome, to kind of foreshadow the future here, is that the planar assemblies hosted on these individual treads and risers have a much more nuanced relationship to the walls on either side. So construction details that manifest into your building sections are going to be more thorough. So in this type of construction, if you're early on in your design process, you should use sloped planes to represent your stairs with a quick stair assembly applied to them. Later on in your process, when you are confident about the floor-to-floor heights and the general layout of the stair in the space, you should draw it at a plane-by-plane basis. Let's go through the process of modeling these two types of planes. To draw a sloped plane, it's as simple as drawing a run, such as 12 feet, and then a rise, such as 6 feet, closing the triangle, and then using the rectangle tool to extrude a horizontal width of, let's say, 5 feet. This is one way to model it. You could have modeled every edge using the line tool. And if you have, for example, a stair that returns with a landing or a stair that changes direction, you can model your landings as separate planes. Again, for 5 feet, for example. If you have, when it comes to the second type of stairs, which is modeled treads and risers individually, the process is also very straightforward. All you have to do is use the line tool. Here, as I type LI to access the line tool, you can now draw the width of a riser, for example. Let's go 4 feet over. Let's go 7 inches up. Let's hold shift to get a snap back to our original point and close it so we have a riser. We can now either draw lines to extend the tread or use the rectangle tool to extend the tread. 11 inches. We now have a tread and a riser that we can use the Move tool's copy mode to start to copy up into a diagonal array. Click, 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 and after a few treads have been added, we can select the whole group and do the same process for the group of treads and risers to quickly amass enough treads to rise an entire story of the building. These planes are now ready to be connected to neighboring walls, for example, by having some kind of support wall here, which when a wall is placed onto it, we will see the serrated top ready to support actual treads and risers. So the process for making these planes is exactly as you'd expect, but the logic behind how to model stairs really has to do with the stage of your project. In early stages, modeling sloped planes is going to be a good enough way to complete your circulation designs, and I just feel like adding an additional sloped plane here for completeness sake. You can still design pretty sophisticated series of rectangular runs using these sloped planes, but when it comes time to get details really down and organized, it is a better fit to model every tread and riser on their own. All right, so that's one of the types of millwork and custom carpentry that is often found in buildings. Next, after stairs, we'll be talking about cabinets. See you there.